Alright, this short video is on the three common states of matter, what they look like, and also the energy changes, and what happens when you go from one phase to another. Okay, so if you look at the three phases that we're talking about, gas, liquid, and solid, and I made this table on here, so I have gas on the top, and so the state is in this first column. What the molecules look like is in this second column, and then the energy, relative energy, is in this third column. So let's first start with solid. So if you look at solids, the molecules are really tightly packed together. They're not moving. They're vibrating, but they're not moving. And they have the lowest amount of energy. If you look at liquids, on the other hand, liquids, they have a little bit more energy. Say they have medium amount. So in other words, the energy they have is between that of solids and gases. The molecules can move around, but they're not moving around very quickly, and they're not moving away from the surface of it. And then we have gas, which is our third state of matter. If you look at the molecules, they're moving around really quickly. If I could look at them, I would see that they go from one place to another, hit a surface, bounce off, and they'll keep on going until they hit something else. Right? They're just moving randomly, and they're doing that all the time. So, and they have the highest amount of energy. Now, if we go from one state to another, there has to be energy change. If I go from a liquid, I start out as a liquid, I convert it to a gas, I am increasing the amount of kinetic energy. That also means that the amount of energy that I have is going up. So in order for a substance like water to go from a liquid to a gas, I have to add heat energy to it. As I add heat energy to it, the molecules are going to move faster and faster until some of them break away and they start flying around. All right, and they'll keep on doing this. Now, if you look at water, and let's say we have a container of water, what we would do, let's see if I can let me erase some of this. I'm going to erase this down here. Okay, let's say we have water. Alright, let me draw a container. Okay, we have a container, and we have water here in it. Alright, let's say this is all water that's in here. I'm going to add heat to it. So let's say I have a fire below. This is my fire. And the molecules are in here. Well, what I would see is the molecules, they would move around in here faster and faster. You see them moving around, and eventually they move around so quickly that some of them break free and they'll go in the air. And that's what we start seeing as steam. Why do they do that? Because I add more energy to the water. They move around faster and faster. Sometimes they'll move around with so much energy, so fast, so much kinetic energy, that they break free from the bonds that hold the water together. And that's when they fly off as steam. Now, if you start seeing bubbles, right? Bubbles forming in, let's say it's water, right? It's boiling. Boiling is actually vaporization, which is converting from a liquid to a gas throughout the liquid. So you start seeing bubbles in here. The bubbles that are forming and rising to the top right? Those are actually filled with water vapor, so water in a gas state. Okay, and then if I'm going to cool it down, right? So if I cool a substance down, so let's say water. We have water, and we convert it from a liquid to a solid, right? So a container with water. And where would we do that? We would probably take it and put it in the freezer. Okay? When we put the water in the freezer, what's going to happen? Heat is going to be released from the water because I've put it into the freezer and it's colder in the freezer than it is in the water. And heat always goes from warm to cool, or hot to cooler. So you're going to have heat being lost. What's going to happen is the molecules are going to slow down. And they're going to slow down so much that they don't have enough kinetic energy to break free from the bonds that are holding them together. And that's when you're going to have a solid. Okay, so in order for the water to go to a solid state, in other words, form ice, I need to remove heat from it. The molecules stop. They stop moving. They'll just start vibrating, but they're not moving from one place to another. The bonds are strong enough to hold the water molecules in place so they're not moving around. Because I've removed the kinetic energy that could help or make them break free. Okay, so that's ice. So when we look at the three phases of matter, I can have an energy change, right? And when I have an energy change, in other words, I can add or remove kinetic energy. When I do that, I can change it from one phase to another. Let me just show one more thing. So, and we can represent that. Let's do this. So I'm gonna, okay, so let's say we have gas, liquid, and solid. And we said that when we are going from a liquid to a gas, you have to add energy. And when we go from a liquid to a gas, we have to add even more energy. On the other hand, if we go from a gas to a liquid, we're subtracting energy. So we're going to subtract it. If we go from a liquid to a solid, we have to actually subtract even more. Okay? And we'll talk about, if you have any questions, ask me during the live session. And if there's a video that you'd like to make that's on another topic that we're covering, let me know when I can make it. Thank you.